In section 5.2, we're taking a look at the sum and difference formulas for our trig functions. So if I have two angles, u and v, and I want to add those angles together and then plug that result into sine or into cosine, the result is going to be what we call the sum formula. Let me first of all just point out that trig functions do not distribute over addition. It's fairly easy to see that, actually, if I imagined that u and v were both pi over 2. Pi over 2 plus pi over 2 would be pi. Sine of pi I know is 0. But sine of pi over 2 is 1. So I don't take sine of pi over 2 and then sine of pi over 2 and add those, because 1 plus 1 would give me 2. Okay. There are lots of examples you can come up with. The trig functions simply do not distribute. Okay. But it is the case that I can express sine of a sum of two angles and cosine of a sum of two angles in terms of four things. Taking the two individual angles u and v, sine of u and cosine of u, sine of v and cosine of v. If I know both sine and cosine of both angles, I can express sine of the sum and cosine of the sum. Okay. And here are the formulas. Sine of u plus v is sine u cosine v plus cosine u sine v. Okay. So what we do is we take sine of one, cosine of the other, multiply those together, and there are two ways to do that, and then we add those results. Cosine of u plus v is cosine u cosine v. We multiply the two cosines together, and then we subtract sine u sine v. Okay. Now, it is possible to derive these formulas. What the book does is it actually starts by deriving cosine of u minus v. There's a geometric derivation given in your text that I'd encourage you to read through, but I'm not going to hold you responsible for that derivation. What I am going to hold you responsible for is knowing these, being able to use them, and being able to use these two to derive other sum and difference formulas. So I won't ask you to derive these two, although I'd encourage you to read through the derivation that's given in your text. But I will ask you to use these to derive some others, and we'll be doing that as we work through the videos for this section. Okay. For these two, I do suggest, and this is rather rare, but I do suggest that you just memorize them. Okay. There are a few things in trig that we just have to bite the bullet and memorize. The geometric derivation, I think, is interesting, but it's not something that is really quick so that you'd have this at your fingertips, and you do want to have these at your fingertips. Now, fortunately, I have a former student who came up with a brilliant mnemonic device for remembering these. So it's a really silly, dorky story, and I love silly, dorky stories, and it helps me to remember the sum formulas. So, it all comes down to the psychology of the trig functions. Sines are very social functions. So when sines go to a party, they love to mix it up and talk to the other trig functions. So you'll see them hanging out with other types of functions. And that, of course, is a very, very positive quality. Okay. Cosines. Very, very antisocial functions. So when the cosines are in charge of the party, they only hang out with their own kind. Of course, that leaves the sines with nobody to hang out with but the other sines, even though they want to be social, but they can't because the cosines are in charge. Not only that, can you believe it? The selfish bastards put themselves first, and that is a very, very negative quality indeed. I love that. Okay? But that helps me to remember the sum formulas for sine and for cosine. Okay. So these are two formulas that we're going to need to know. And we're going to be able to derive sum and difference formulas for a bunch of things. What I'm going to do right now is I'm going to derive the difference formulas from the sum formulas. Okay. So if I wanted to look at sine of u minus v, what I would do is I would simply write that as sine of u plus the opposite of v. So I can always write subtraction as addition of the opposite. Now, if I do that, then I just am plugging into this formula. If anywhere I had a v, I'm now replacing it with the opposite of v. So that's going to become sine u cosine of the opposite of v plus cosine of u sine of the opposite of v. But now I can use my even odd identities. I know that cosine is an even function. So cosine of the opposite of v is the same as cosine of v. So this is just sine u cosine v plus cosine u. Now sine is an odd function, so sine of the opposite of v is the opposite of sine v. And usually what I'll do is, rather than having these parentheses to show that I'm multiplying by a negative, I'll bump that negative to the front. So it becomes sine u cosine v minus cosine u sine v. So essentially it's just the sum formula, but with a negative sign instead of a positive sign. Kind of cool. Okay. Because it's so similar to the sum formula, I might have that memorized, but it's very easy to derive. And I could ask you on a quiz or an exam to simply state the sum formula and then use the sum formula to derive the difference formula. And that would be having you do this work. Okay. What I'd like you to do right now is do the same thing to derive the difference formula for cosine. So I'm going to just remind you, cosine of u plus v, cosines are the antisocial ones, so that's cosine u cosine v minus sine u sine v. What I'd like you to do is derive the formula for cosine of u minus v. The same way we just did it for sine of u minus v, you're going to rewrite this as adding negative v. Then use the sum formula and simplify it. So pause the video and work that one out. All right, I've got the answer up here. Notice I just rewrote u minus v as u plus the opposite of v. So then I plugged into the sum formula, just replacing the v with the opposite of v. And then since cosine is even, cosine of the opposite of v is the same as cosine of v. Since sine is odd, sine of the opposite of v is the opposite of sine of v. But rather than having these parentheses, I just moved that negative to the front. It combined with the negative that was already there, so we end up with cosine u cosine v plus sine u sine v. Okay. Pretty nice. It's basically the sum formula, but with the sign changed. Okay. So the difference formulas for sine and cosine are the same as the sum formulas, except that you change the sign, the plus or minus sign connecting the two terms.